Hey, and welcome to the lab. My name is Mike. Today we're starting off our basics series. We're looking at the Raspberry Pi single board computer. We are examining what this is and how it is important to the maker community. We will use this single board computer in a large number of our projects. So let's take a detailed look at what they are and what they do. So lab code up. We're going to learn something today. So what is a Raspberry Pi? The short answer is that it's an ARM-based single-board computer. Okay, so what does that mean? Well, let's look at the first part of that statement. ARM-based. That is the processor that is on the board. It's part of a family of processors known as ARM processors. This is like the CPU in your full-size desktop. Chances are you use an ARM processor every day and are just not aware of it. The majority of smartphones use a processor that is based on the ARM architecture. The second part, single board computer, is exactly what it sounds like. It's a full computer system on a single board, which means that it can run full operating systems that used to be reserved for PCs and servers. Common operating systems that run on this little guy are various distributions of Linux, Android, and even Windows 10, sort of. Well, this thing has to be expensive, right? About $100 at least, right? No. Depending on the model that you are looking at, the price varies between $13 Canadian and $50 Canadian. Now that's cheap. That's right, a computer capable of running a full distribution of Linux for $13. Just add an SD card, a keyboard, a mouse, and a monitor, and you're off to the races. But we will get into that in a little bit. It is important to note that a Raspberry Pi is not one thing. There are many different models. Each have their own strengths and weaknesses. In our video series, we are going to be looking at 4 specific models. The Raspberry Pi 2 Model B, the Raspberry Pi 3 Model B, the Raspberry Pi Zero, and the Raspberry Pi Zero W. We will also touch on the compute module, which is a product that there is no current plan projects for, but is a neat concept, and in the future we might find one where its unique attributes fit best. Of these 5 models, there are 3 different form factors that are found. The Raspberry Pi 2 and 3 have a full credit card sized form factor, as shown here. Physically, the size of the device is only 85 millimeters by 56 millimeters, or roughly 3.5 inches by 2.25 inches. The Raspberry Pi Zero series is even smaller, at 65 millimeters by 30 millimeters, or 2 5/8 inch by 1.25 inch. Other than the size, there are some key differences. The processor speeds are different between the models. Specifically, the V2 has a 900 MHz quad-core ARM Cortex-A7 processor, 1 GB of RAM, Ethernet, USB, audio, and HDMI are on board. The V3 has a 1.2 GHz 64-bit quad-core ARM V8 CPU, 1 GB of RAM, Ethernet, Wi-Fi, Bluetooth, USB, and HDMI on the board. The Zero, which is designed for more low power applications, has a 1 GHz single core CPU with 512 megs of RAM, HDMI, and USB on the board. And the Zero W brings the same specs as the Zero, but it adds Wi-Fi and Bluetooth on board, which makes it great for Internet of Things projects. So let's go take an up-close look at these devices. Alright, so what we have here is a Raspberry Pi Model B version 2. Just going to do a quick overview of everything that is on this board. how it compares to the other boards in the series, and then we'll take a look at how we use it. So first off, we have the GPIO header here, which is a 40-pin header. Contains pins that we can connect into the computer with. We can provide power or receive power from. I will put a pin out of that header at the top of your screen right now. This connector here is for a ribbon cable to a display module. The Raspberry Pi does have native display modules that are available. I personally have never used one, and I don't know many people that do, simply because the HDMI port is very convenient and the composite out for video is also very convenient. Now moving across the board, we have the main processor here, which, as I talked about before, is an ARM-based processor. This one is made by Broadcom. If we look over to this chip here, this chip is a USB and Ethernet controller, which provides us the 4 USB ports and the 10100 Ethernet port. This here is a micro USB connector. All it's primarily used for is to feed power into the device. Now, as I said, you can also do that via the GPIO, but a USB connection is very, very convenient as well. I would recommend at least a 1 amp power supply to this board, otherwise you may get power warnings. As well as I've mentioned, there's an HDMI port that is on the device itself. This will hook up to any HDMI monitor or any HDMI consumer. It does have the CEC pins mapped, which we'll talk about later, and is a great way to get a display onto this device. There's another ribbon cable connector directly beside that. This is for the Raspberry Pi camera module. You can connect cameras through USB, but Raspberry Pi has a specific one that goes into this board and offers just a little bit more bandwidth from the camera. I would recommend using this with any OpenCV or computer vision type projects that you plan to do. This is a 3-channel phono jack. What it provides us is audio out and composite video out. You use it with one of the cables that has like a headphone jack and 3 RCAs at the other end to give you analog video, analog audio, both left and right channels out. If we flip the board over, we have the RAM chip here. On this particular model, that's 1 gig of RAM. And we have the SD card slot right here. Now, the SD card in this particular type of device functions as the hard drive for a computer. I would recommend staying in the class 10 range and no smaller than 8 gigabytes. Thank you for joining me in the lab. If you liked what you saw today, give me a thumbs up. If you have any comments, questions, any clarifications, suggestions, anything really, comment section below. Don't forget to subscribe, and I hope you learned something today.